Hello, welcome again to the lecture series on automobile engineering. In this session, let us learn the construction details in the working of automatic transmission system. In the previous session, we have studied about the torque converter. Now, torque converter will drive this automatic transmission system. The fundamental principle is that in an automatic transmission system, you will have a planetary or epicyclic gear train system. So, let us understand what exactly an epicyclic or planetary gear train system. In this figure, I have shown the epicyclic gear system. Mainly, we have a sun gear at the center, sun gear. Around the sun, planets revolve. So these are planet gears. Planet gears. These planet gears are mounted on an arm. And this one is the ring gear. So by having the relative motion between any two gears, we can obtain a speed ratio. What I mean by that is, suppose if I hold this ring gear stationary, if sun gear becomes the driving gear and the planet gears become driven gears, then I can have one speed ratio considering sun gear as the input gear and this is the output one, so we can get one gear ratio or so that a speed ratio. Similarly, I can hold sun gear stationary. I can make a ring gear as an input gear and again I can make this as an output. So I can obtain another speed ratio. Okay. Another possibility is that I can hold this stationary and using these two pairs I can get another speed ratio, maybe in the reverse direction. So that way it is possible using this planetary gear system to obtain a different speed ratios. Now let us calculate how exactly we have to set the gear ratios. In a gear system, you know very well, two gears have to mesh together and run. Then the module of one gear must be equal to the module of another gear. We call it as module. Module is defined as diameter by number of teeth. Mean diameter of the gear to the number of teeth of the gear. So module 1 is d1 by z1, module 2 is d2 by z2, they must be equal. I can write now z2 by z1 must be equal to d2 by d1 or 2 times the radius of r2 and 2 times the radius of r1. Look here. These two are meshing. When they are rotating, the linear speed should be same. That is v. V is what? Pi d1 n1 by 60. This must be equal to pi d2 n2 by 60. Okay. If you want, we can write like this also. 2 pi r1 correct 2 pi r r1 N1 by 60 is equal to 2 pi R2 N2 by 60. I can write. We can also write this as 2 pi n is omega 1 R1 and be equal to omega 2 R2 I can make. Or I can write R2 by R1 is equal to omega 1 by omega 2. Or this one also I can write it as, you see here in this equation, if I calculate this, if I can cut off this kind of thing like that, d2 by d1, or you can say 2r1, r2 by r1, you can also write n1 by n2. So it is in terms of rpm, this is in angular velocity, this radius. So that's what you can call this as the speed ratio. You can relate with a radius. That means you can relate with number of teeth. Okay, if you fix the number of teeth of the output input gear, and we can get the required speed ratio. So now let us do some gear ratio calculation. For that, this is the sun gear. If I just draw a horizontal line through the center, this will give you the radius of the sun gear. This will give you the diameter of the planet gear, or 2 times the radius. That is nothing but the radius of the ring gear. So radius of the ring gear is equal to Rs plus 2Rp, I can write. Now, as I mentioned already, this equation I derived, V1 must be equal to V2, and this equation I is equal to speed ratio omega 1 by omega 2 is equal to R2 by R1 is equal to Z2 by Z1. We have already derived this equation. Now let us call the speed ratio or gear ratio I. This is sun gear, this is carrier. I told you omega is not, this V must be, the linear speed must be angular speed under radius. Correct? Linear speed of the carrier is equal to omega c Rs plus Rp. Correct? You can go to this one, Rs plus Rp. So this one, this radius about this point. Okay, fine. Vs, that is sun gear, omega s Rs. Suppose Vs is equal to 2 times Vc. So Vc is nothing but this value, you bring it here. Correct. So Vs is omega s Rs. This is 2 omega c Rs plus Rp. So omega s by omega c, which is equal to I, from this equation you will get this. So 2s plus 2rp by rs is also equal to 2rs. So you can write this 2rp. Rp, that is rr minus rs divided by rs. Finally you will get I is equal to 1 plus rr by rs. That is ring gear radius by sun gear radius. Okay, this is nothing but again number of teeth. So I is equal to this, I replace by zr by zs. If there are 12 teeth on the sun gear, if there are 60 gear on this thing ring gear, then I is equal to 1 plus 5, that is 6. That is sun gear speed is equal to 6 Wc. Correct? So this is how we get the gear ratio, like the speed ratio. Fine. Now let us look at, assume that the ring gear has 72 teeth. and Sun gear has 30 teeth. So there are three gears here: Sun gear, planet carrier or planet gear, and ring gear. So here I have shown you make one as input, another one as output, third one you hold stationary. Suppose in case A, let us say I make Sun gear is a driving gear. It is driving gear. It gets the input. Sun gear is, let us say, driven by the turbine shaft. Now I'll take out the output and the planet carrier, keeping the ring gear stationary. Then you see here the gear ratio, by substituting in this equation R and S, you are going to get this one. So already we have derived that WS by WC is equal to 1 plus RS we have derived. Substituting the value, this you see here 72, this 30 I'll substitute, I'll get this one. Same way, if I do the derivation and hold planet carrier as the input, make ring gear as the output, keep Sun gear as stationary, great, then you will get a relation like this, and put the teeth number and substituting that you are going to get this one. Same way, now make Sun gear as the input, ring gear as the output, hold planet carrier as this thing, you are going to get the reverse minus. That's how we can set the gear ratios. Now how do we do the gear ratio calculation? There is a detailed lecture available at this website. Please visit this website and study, understand this. This is a continuation of that. Now how planetary gear system works, also available on the YouTube at this link. Please click and watch this. It's a beautiful video. Okay, so this is actually the video. You click on the YouTube and you understand that. That's not a problem at all. Now let us now continue the concept of epicyclic gear train for developing a multi-speed automatic transmission system. Look here, I have Sun gear, planet gear, ring gear. This is one gear train. There is another gear train like that. Another gear train. 3 gear trains. So now the thing is, by combination of one gear you fixing and having relative motion between 2 gears, that output you are connecting it to the next gear train, and that again applying the required constraints, and that output connecting it to the final this thing. Finally you can get the output over here. By different combinations, it is possible to obtain different speeds. So that we will understand how exactly we can obtain different speeds in this automatic transmission system. So if you look at in an automatic transmission system in your car, this is a gear changing lever. You can find these letters. So if you put your gear train lever at this position, this is parking position, this is reverse position, neutral position, and drive. So here, depending on the torque required, depending on the speed required, automatically the gear positions change. That means to say, in the epicyclic gear train system, so which has to be fixed, which has to be released, depending on that, an automatic control system will organize those combinations, and you will be able to get different speeds. How exactly, what are those combinations? Let us understand now. Before getting into the 2D illustrations of that, I have just shown a complete automatic transmission system used in BMW vehicle and developed by ZF. can see here you have the torque converter system, and here you have the automatic transmission system. Automatic transmission system we have. In this automatic transmission system, you can observe a set of epicyclic gears. Also, you'll have clutches. You'll also have brakes, all these things. So to operate these clutches and brakes and all that thing, you have the hydraulic system. Correct? This hydraulic system will give the required power to the brake into apply those clutches, and it is possible which one to hold, which one to release, and all those kind of thing, and it is possible to get different combinations. So based on the control logic, this will be the hydraulic fluid will be made to flow to the various brakes, and these brakes in turn will operate those clutches. This is the complete system. Now let me get into to understand these combinations. Let me show the 2D details, 2D illustrations. So let us say it is an automatic transmission of 6 speeds. You can see this input shaft. This is connected to or driven by the turbine. And please look at this. This is also connected to this. This rotate means this also can rotate. Correct? Rotate. This can rotate. Suppose this is the clutch part I was talking about. If I apply this clutch by applying the force like this, if I can bring them together, they get locked. So when this rotates, because it is getting locked, this will also rotate, and so that this shaft rotates. So this is mounted on this. This can also drive this. So it is possible by operating those clutches, we can constrain their motion and we can operate a particular combination to get the required speed ratio. Here let me show you this. This is the input speed. These are all the clutches. Fine, you have understood those things. Now you see here, I have one epicyclic gear train system. Say this is the sun, this is the planet, and this is the ring. So over the ring gear, you have clutches. Correct? And as you have seen in the previous figure, okay, using these clutches can be operated using those hydraulic power. Correct? By applying the brakes, using that hydraulic power, we can engage these clutches. So again you see another system here. Again you have sun gear, you have planet gear, you have ring gear. Sun, planet, and ring gear. And finally you can get the output from this. Right. Let us now obtain how I can get the first gear, one particular speed ratio. As I mentioned, this is coupled to the turbine of the torque converter. As the turbine rotates, this fellow will be rotating. But what we have done is, we have engaged this clutch. When we have engaged this clutch, what happens when this rotates, this whole thing has to rotate. So this rotates means this sun gear will rotate. This sun gear will drive this planet gear. See here, this ring gear is stationary, right? Because here we have applied the force. So this is the combination you will get, and based on as per that formula, you can find out the number of teeth and all that thing, and you will be getting the output speed here. This is how we will get this way. Okay, next. Let us say, how do we get the second gear? Again, this is driven by the turbine. You lock this. When you lock this then this will become a single part. As this shaft rotates, this has to rotate. correct? Then this will drive the shaft. Yes, this will rotate. This will rotate. You can see over here what has happened, right? This part, okay, it's driving this. So here I have released this. This is the kind of thing. So we have released. So now we are going to get, this is also rotating now, correct? As this rotates, this will also rotate, and this is free now. So now we are going to get another speed, right? This will rotate and you will be getting the speed. Okay, so you will get another combination. Here it is clearly written, it rotates and this is rotating, and you are going to get the output speed, right? Similarly, direct drive. So you can go on looking at those kind of combinations. It's possible to obtain different speeds. This is the direct drive. So this is how the illustration. So beautiful. It is taken from the YouTube video only. I have taken those particular slides and to understand how exactly an automatic gear train system works to obtain different speed ratios. Is another, right? So the way I analyze, the same way you analyze, you understand how exactly different speed ratios can be obtained. Okay, third gear combinations. Okay, fine, sir. So then after this, after understanding this, you click on this video, right, on the YouTube. So on this link, if you click, you can straight away get. Otherwise, you can search on the YouTube and you study this. You just watch this, and you will understand how exactly an automatic transmission system works. This is the video actually, right? And operations of the valve body and the friction element is also given, is also illustrated or explained in this video. So this is also available on the YouTube. Now, as I said, how exactly these things happen? There must be a control system. You call that control system as a transmission control unit, or simply you call it as TCM, transmission control unit, or TCM they call it as a module also. So now you have sensors, various sensors, throttle position sensor. You know, if the driver is putting pressure on the throttle sensor, means he's opening more and more throttle, means he's looking for higher and higher speed. Probably he takes out the pressure on that, it means he's looking for low speeds, and so on like this. So based on the throttle position, the system understands the intention of the driver, whether it has to be accelerated or it has to be deaccelerated, and so on like this. And there is a vehicle speed sensor from which you can measure the speed of the vehicle. Also, for every wheel there will be a wheel speed sensor. It is omega. It is definitely required to operate the traction control system or ABS. These values are very much necessary. So then the turbine position sensor will be there. Yes. So this is just the turbine, right? Position relative to, you know, the pump and these things. So turbine position sensor, that you can see. Then the transmission fluid temperature. Yes. Then the traction control system operation if required. Using these values, you can operate the traction control system. Speed can be controlled. Then the brake light switch like this. So based on these required, what is the speed required? Based on that, you know, the solenoids have to be operated or these clutches have to be operated. So they decide which clutch has to be opened, which clutch has to be up, is to be locked, and these things. The ECU will send a signal to these things, and accordingly the hydraulic power system will supply the pressurized oil to the brake system to apply or release the clutch. This is how we are going to get. Okay, so these are the torque converter, clutch solenoid, that is whether it is to be locked, whether it is not to be locked, that those kind of conditions depending on the relative speed between the impeller and the turbine, this will decide. So again, what is the amount of pressure that is required to apply the force. All these things will be decided by this ECU, and accordingly it will be operated. So you do not have to worry about those kind of things. Based on the intention of the driver, the speed automatically, the positions will change, different speed ratios are obtained, and finally you will get the output. So unless you have a transmission control system, it's not possible to automatically decide the speed ratios. So that's how the transmission control system works. Definitely, if you study automotive electronics, we can study very much in detail about all those kind of things. Here, to give an idea how exactly who does them, when to change, and how to change, and all those things. So to indicate that the transmission control system has been explained here. Okay, so how exactly the transmission control module works, that video is also available on the YouTube. You can visit that, you can watch that and understand how exactly it operates. Now let us look at something like what exactly the difference between automatic transmission versus manual transmission system. There are two things over here. One is what you call it as tractive effort versus vehicle speed. The engine develops a tractive effort like this, and a vehicle will have three resistant forces, that is aerodynamic resistance, gradient resistance, then rolling resistance. That graph, if I plot, is how we are going to get. And this is the maximum speed of the vehicle. So to achieve this, probably initially we require very high tractive effort. Correct. Then depending on to overcome that tractive effort, we use first gear, second gear, and so on like this. This is what you can call it as the tractive resistance. And this is what you call it as a tractive effort curve and all that. So suppose if I draw that tractive effort required, so initially you require more. As the speed increases, the effort required will reduce. So here more resistance is there. To overcome this resistance, we use the first gear. Suppose if I apply the first gear and all that thing to achieve this kind of a thing, initially the engine speed increases, reaches to the maximum torque. After that, if I further open the throttle, the engine, even in the first gear, the tractive effort developed will reduce, and finally engine rises, the vehicle will stall. So for that, if I apply the second gear, it is going to happen like this. This has been explained earlier, like third gear, fourth gear, like this. But in an automatic transmission system, look here, this tractive effort versus speed. Yes, initially you require a very large tractive effort. I apply the first gear. So now I go on increasing the speed of the vehicle. You can see over here, this is not something like that. It is coming and stopping, like what we experience in a manual transmission system. Instead of that, it is definitely the tractive effort is decreasing like this. It is tipping. The reason being that you have the turbine and also the impeller. This is the impeller, this is the turbine. Between these two, the slipping happens. Correct? So that is what exactly here. Slips, then amplifies, again engages, again slips, it again amplifies the force. That's the kind of a thing that happens. That's how you see here the ability to drive, accelerate the vehicle will come down. But it is not like this. The vehicle will not completely stall in this case. Definitely there is going to be a slip. There is a difference that you can find in an automatic transmission system compared to a manual transmission system. We also have something like continuously varying transmission system. Whether you take manual transmission system or automatic transmission system, so we have limited number of speed ratios. Maybe you have 5 speeds or 6 speeds and all that. If you go on increasing the number of speed ratios and all that, definitely the fuel economy and all those things can be improved, but your gearbox or transmission system becomes more complex. To avoid those kind of a complexity, like you can think of having continuously varying transmission system. The whole idea is that suppose one is the driving shaft and the other one is the driven shaft, and in between these two we have to get a speed ratio. We want to get something like infinite speed ratio. The idea is it is a variable diameter pulley. This is also a variable diameter pulley. So its linear speed is something like that. You can say pi d1, say n1, or just to assuming RPM it is 60. Simply its speed is like this, pi d2 n2 by 60. So the distance between these two will remain the same. Correct. Now the question is, that means to say their linear speeds are same. That means to say d1 n1 is equal to d2 n2. So here I can get n1 by n2 is equal to d2 by d1. By varying the diameter ratios, it is possible to obtain. So if I have a pulley whose diameter can be varied continuously, it is possible to get infinite number of speed ratios. That's what exactly happens in a continuously varying transmission system. Now, this is the principle, but there are many different designs available. This is one of the designs which I have explained. You can look at YouTube. This particular video, if you look at, it will explain you how exactly we can vary the speed and what are the different designs of continuously variable transmission system works. We also have something like dual clutch transmission system. What do you mean by the dual clutch and all that? You just see here is a transmission system. Maybe it is a constant transmission system, whatever it is. So these are even gears, second gear, fourth gear. These are odd gears, say 1, 3, 5 and all that. So these gears, you can see here, you have one clutch system for that. So engage or disengage this clutch while changing odd gears. Engage this clutch or disengage this clutch while operating these gears. So the idea here is to reduce the time. So 1, then you go to 2, then you go to 3, then you go to 4 and all kind of things like that. Instead of that, even to even you can change, or to odd you can change, and you can reduce the time. So that means to say the vehicle speed variations can be very much reduced. That's what we call it as a dual clutch transmission system. So a two-part transmission shaft is at the heart of a DCT. Unlike a conventional manual gearbox, which houses all of its gears on a single input shaft, the DCT splits up odd and even gears on 2 input shafts. So the outer shaft is hollowed out. Okay, this is how it is explained. But the whole idea of this thing is one clutch controls second and fourth, while another independent clutch controls first, third and fourth. That is the trick that allows lightning fast gear changes and keeps power delivery constant, which I explained. That is the idea of dual clutch transmission system. So this is how the automatic transmission system works. So now you have understood how the manual system works, automatic transmission system works, the difference, the advantage, and the recent developments in transmission and all this. So at this point, let us stop our discussion on transmission system. In the next session, we'll talk about transfer cases. Right? Till then, thank you very much.